Hi everyone. In today's lesson, I'm going to explain how to use substitution when the problem has an e or a fraction. So the first thing that I'd like you to do is pause the video and grab a piece of paper and then hit resume when you're ready to take notes. Okay, so let's title our page Substitution with ln and e. All right, so first I'd like to review the derivatives. So if I have y equals ln of x, we know the derivative, dy dx, is 1 over x. And if I have y equals e to the x, we know the derivative, dy dx, is just e to the x. So if I want to go backwards and I want to take the antiderivative, so the antiderivative of 1 over x dx is nothing other than ln of x. But we just have to remember that ln of x has to be in these absolute value bars here because ln is like a log, and inside these parentheses always has to be positive. Okay, so now what if I want to take the antiderivative of e to the x dx? You should say that the antiderivative is just e to the x. Now obviously these are plus c's, but those are the concepts for the integration. Okay, so let's do an example now using substitution. Okay, the first problem I'd like to do is this one here. So let's copy it down. So we have example number 1. So we want to take the integral of 15x to the 4th times e to the 3x to the 5th plus 1 dx. So all of this is what I want to integrate. So the steps that we did for polynomials are still the same. We still need to find a u, we need to find du, and then solve for dx. So in this situation, because we have an e, our u is going to be that exponent. So I'm going to put some steps over here. So step 1, let u equal the exponent. And then, as we did before, step 2 will be to find du. And step 3 will be to solve for dx. Right? Just like we did yesterday. So, step 1. Let's start with u. So u is equal to this exponent up here, 3x to the 5th plus 1. So u is equal to 3x to the 5th plus 1. Step 2, find du. So we want to take the derivative. So multiply the exponent 5 and the number in front, which is 15x, and drop the power down by 1. And the derivative of a constant 1 is always 0. And remember, we always have to put dx because we're taking the derivative with respect to x. Then next, we're going to solve for dx. So divide both sides by 15x to the 4th. So my dx is du over 15x to the 4th. So now that we have all that information, we can go ahead and go back to the original problem. So the 15x to the 4th stays. So we're going to rewrite this as the integration of 15x to the 4th times e. But now instead of this 3x to the 5th plus 1, we're going to write u, because that's what we let u equal. And instead of this dx, we're going to write here what we let dx equal. So we're going to multiply this by du over 15x to the 4th. Now, before we can integrate, we have to get rid of these x's that we see here, right? We can't integrate, this has a u, this has a u. We have to get rid of these x's. So it looks like they actually divide out nicely. This 15x to the fourth and that 15x to the fourth divides. So we want to integrate e to the u du. And you should be remembering that the integral of e to the u is just e to the u. So e to the u plus c is my final answer. Now not really final, excuse me, we actually have to now resubstitute what we let u back in. So if you look over here, we let u equal the 3x to the fifth plus 1. So my final answer is e to the 3x to the fifth plus 1 and then plus c. So this is my final answer. Awesome. Let's try another example. So example number 2, we have an integral of 4x to the third over x to the fourth minus 3, this whole thing, dx. So if you notice, in this problem, we don't have an e anymore, right? There's no e in the numerator, no e in the denominator. So what we're going to let u equal, step 1, is let u equal what's in the denominator. Step 2, same as before, we're going to find du. And step 3, we're going to solve for dx. So, if I follow those directions, I'm going to let u equal what's the denominator. So the denominator is x to the fourth minus 3. I'm going to take the derivative, so du. Again, drop the 4 in front and reduce the power by 1. The derivative of a constant is 0, and we have to write dx next to it. Then I just need to solve for dx. So I'm going to divide by 4x to the third. So du over 4x to the third is what dx is. So now that we have all of our information, we're going to go back to the problem, and my 4x to the third can stay on the top, and the bottom is u, and the and the dx is du over 4x to the third. Now what you should recognize is that these 4x to the thirds cancel, but they don't just disappear. Anything divided by itself is 1. So then when we rewrite this, we want to take the integral of 1 over u du. And you should be recognizing that 1 over u is the same thing, or the integration of that is ln. ln of the absolute value of u plus c. And the final step is to put u back in. So the u was x to the fourth minus 3, and then plus c. So this is your final answer. Awesome. Okay, I just have 2 more examples that I'd like to get through. So example number 3 is the integral of 12x squared e to the x to the third minus 2 dx. So what I actually like you to do is pause the video, try this one on your own, and then hit resume when you're ready for the explanation. Okay, so like we did before, the u is going to be the exponent. So u is x to the third minus 2. Du is my derivative, which is 3x squared dx. Divide both sides by 3x squared. And dx is du over 3x squared. So when I go back to my original problem, I leave the 12x squared times e, but now the exponent is a u, and the dx is du over 3x squared. And what you should notice is that just the x squareds cancel, and when you divide 12 and 3, you should get 4. So I want to integrate 4e to the u du. And just because there's a number in front of this e doesn't change the derivative or the antiderivative. The antiderivative of 4e to the u is 4e to the u. So the final answer is 4e to the u plus c. And then just don't forget to put your x back in. And this is your final answer. Perfect. Let's try the last example. So I'll call this one example number 4. And I want to integrate negative 8x to the third over x to the fourth minus 5. So because this is a fraction, we're going to let u equal what's in the denominator. The denominator is x to the fourth minus 5. Then I want to find du. So the derivative of u is 4x to the third dx. The derivative of 5 was just 0. And then solve for dx. So dx is du over 4x to the third. So we go back to the original problem, and we have negative 8x to the third over u. Oh, I'm sorry, I forgot to put the dx here. So then my dx, I'm plugging in, is du over 4x to the third. Now what you should notice is just the 4x to the thirds cancel, and that negative 8 divided by 4 is negative 2. So we have the integral of negative 2 over u du. Now this one's a little bit harder to see. You have to break up this negative 2 over u as negative 2 times 1 over u. And when you integrate it like this, you can see how they're kind of like 3 separate pieces. And this piece right here, the 1 over u, is your ln. And this negative 2 is just a constant that gets multiplied at the end. So you can even see me take this negative 2 and pull it on the outside. So negative 2 times the integral of 1 over u du. And you can say, okay, the integral of 1 over u du is just ln. So ln of u plus c with the negative 2 on the outside. So then the final answer with x's are negative 2 ln absolute value of x to the fourth minus 5 plus c. This would be your final answer. All right, that's it for today's lesson. If you have any questions, please let me know. Have a good day.